he was right. Michio Kaku was absolutely right when he said that the discovery of the James Webb Space Telescope would challenge our understanding of the beginning of the universe. The telescope has discovered 10 galaxies that appear to be older than the universe if our current standards and calculations are correct. But how can that be? Are we looking into a parallel world, or did our scientists just get it wrong when they claimed that our cosmos was created 13,800,000,000 years ago by an event called the Big Bang? Michio Kaku emphasizes that it takes many billions of years to form a galaxy like the Milky Way, which has 100 billion stars or more. However, telescope James Webb discovered 6 galaxies that existed just half a billion years after the Big Bang, and were 10 times the size of the Milky Way. This contradicts previous assumptions that there should not be such large and old galaxies at such an early stage in the evolution of the universe. Just as he suggested that as a result of these discoveries, our theory of the origin of the universe may have to be revised. Let's take a look at these theories. The science of the universe as a whole rests on a few fundamental theories going back to Newton's theory of gravity, and that was in 1687. Isaac Newton's The Mathematical Beginnings of Natural Philosophy describes gravity as a universal force of attraction between masses. Newton's theory was accurate enough for many everyday phenomena, but in space it reached its limits and was extended by Einstein's general theory of relativity for large masses and high speeds. In 1915, Albert Einstein revolutionized our understanding of gravity. The general theory of relativity describes gravity as a curvature of spacetime caused by mass. To this day, it remains the best theory to describe gravity and the dependence of general physical forces in the universe. General relativity fits particularly well on large cosmological scales and in the neighborhood of massive objects such as black holes. However, it fails in the world of subatomic particles and in the realm of dark matter and energy. The Big Bang theory goes back to Georges Lemaitre, who, based on Einstein's theories and astronomical observations, postulated that the universe began as an extremely hot and dense point, and has continued to expand ever since. Since 1927, this has been a major assumption in cosmology. Although this is a purely mathematical construct, it became a kind of truth that many people still believe to this day. In 1980, the inflationary theory, conceived as an extension of the Big Bang theory, appeared. Astrophysicist Alan Good and others postulated an extremely rapid expansion of the universe in the first instant after the Big Bang, which could explain some phenomena that were inconsistent up to that point. Dark matter and dark energy are also two concepts that have almost become physical truths, although there is no proof of their existence. The theory of dark matter and dark energy basically states that dark matter affects the motion of galaxies and galaxy clustering through its gravitational effect, and dark energy is said to be responsible for the accelerated expansion of the universe. Both of these hypotheses have been advanced to explain some astronomical observations that do not agree with existing theories. However, the gravitational effects allegedly caused by dark matter can be explained in another way. Around 1920, an alternative theory emerged that could explain gravitational effects in the universe without assuming the existence of dark matter. In the 1980s, Israeli physicist Mordecai Milgram developed this approach further and named his explanatory model MOND, which stands for Modified Newtonian Dynamics. According to Newton's theory of gravity and the general theory of relativity, the rotational velocities of stars and galaxies should decrease with increasing distance from the center. However, observations show that stars in the outer regions of galaxies rotate faster than these theories actually allow. Traditionally, this has been attributed to the existence of dark matter, which exerts additional gravitational forces. Mott postulates that Newton's theory of gravity is no longer valid for the very weak accelerations that occur in the outer regions of galaxies. Instead, the approach proposes a modification of the laws of gravity that does not require the presence of dark matter. So far, however, none of these theories have been able to explain all of creation. So let's also look at two other fascinating theories: string theory and M theory. Both emerged in the late 20th century in an attempt to unite the world of large phenomena, such as stars and galaxies, with the world of the smallest phenomena, quanta and subatomic particles. String theory suggests that the fundamental building blocks of the universe are not point particles but vibrating strings. If we then assume that there are about 10 dimensions of these strings, most of the macrocosm formulas can be reconciled with the physical laws of the microcosm. There are 5 variants of string theory, and they have been combined into what is known as M-theory. It extends the concept of one-dimensional strings to multidimensional objects, so-called membranes. String theory and M-theory are pure speculation and have not yet been confirmed experimentally. What does Maisie's galaxy reveal? The Maisie galaxy was named in honor of the daughter of astronomer Stephen Finkelstein. Finkelstein discovered the galaxy on his daughter's birthday. And this discovery is likely to go down in the history of astronomy. With an estimated age of just 390 million years after the Big Bang, this galaxy is a window into an era of the universe we barely understood. The Maisie galaxy gives us a glimpse into a time when the age of the universe was only about 2.8% of its current age. This discovery challenges our previous assumptions about the timescales of galaxy formation and the role of dark matter in this process. Dark matter is thought to make up about 85% of all matter and plays a central role in current models of galaxy evolution, but it has a catch. We cannot see it, its existence is definitively unprovable. Dark matter does not interact with electromagnetic radiation. It does not absorb or emit light, so it remains invisible to telescopes. The existence and properties of this mysterious mass are perceived mainly through its gravitational effects on visible matter and the motion of galaxies and galaxy clusters. Standard models of cosmology believe that dark matter contributes to the formation of galactic halos, in which visible matter then accumulates and eventually condenses into stars and galaxies. The discovery of the Maisie galaxy and other similarly old galaxies raises new questions. Not only are these galaxies older than expected, but their size and structure seem to contradict existing models. Until now, it was assumed that it takes billions of years to form complex and massive galaxies like the Milky Way, which contains about 100 billion stars and has a diameter of about 100,000 light-years. The existence of galaxies formed just a few hundred million years after the Big Bang may be evidence that the processes of star formation and galaxy evolution may be faster than previously thought, or these discoveries may definitively disprove previous theories. These observations may suggest that ordinary matter, the kind that makes up stars, planets and ourselves, may have played a more important role in the early evolution of galaxies than previously thought. This contradicts the prevailing view that dark matter was the dominant factor in this process. The discovery of the Maisie galaxy is not only a challenge to the Big Bang theory, but to all previous models of galaxy evolution. The fact that galaxies like the Maisie galaxy existed at a time when the universe was supposedly still in its infancy sheds a whole new light on the conditions of the early universe. A time about which we have so far drawn conclusions only from theoretical models and not from direct observation. Wasn't that what happened? The James Webb Space Telescope's discovery of extremely old galaxies, especially those that may be older than previously thought, is challenging a number of established cosmological theories and giving impetus to variants such as the Mond theory. In particular, the Big Bang theory and related models of galaxy evolution are now being put to the test. However, we must be clear that these new discoveries do not necessarily overturn all these theories. Some of them may well need to be revised, expanded and clarified. The Big Bang theory postulates that the universe began from an extremely hot and dense initial state and has been expanding ever since. The discovery of very old galaxies may cast doubt on the timing of this expansion, especially when you consider that these galaxies existed in a highly evolved state 300 million years after the Big Bang. Since galaxies, as Michio Kaku mentioned, take billions of years to form, something in the calculations here may not be quite right. For in that case, these galaxies would be older than the universe itself. However, this does not necessarily mean that the whole theory is wrong. Perhaps the universe is just much older, 20 or 50 billion years older. Inflationary theory explains how the early universe expanded exponentially in fractions of a second. But the speeds and structures assumed so far are not consistent with James Webb's discovery of very old galaxies. But we may also be fundamentally misunderstanding something about the formation of matter. Traditional models of galaxy evolution are based on the assumption that it takes a long time for large and complex structures like the ones we just saw to form. The existence of these very old galaxies may also simply indicate that these processes may be occurring faster than previously thought. Perhaps the galaxies discovered by James Webb, jokingly called the destroyers of the universe, will also refine our knowledge of dark matter and dark energy. For those with an open mind, the discovery of the James Webb Space Telescope may be an opportunity to improve on existing theories and get a little closer to the truth. Even crazier: Schrödinger's galaxy. Scientists who are already tearing their hair out over the mazy galaxy are truly freaking out over the Schrödinger galaxy. This mysterious object was also detected by the James Webb Space Telescope. This galaxy has two very different values for normally reliable age measurements. Therefore, it gives the impression that she is in two places or two tenses at the same time. Anyone with any familiarity with quantum mechanics knows that this is a typical property of the quanta of light particles that make up matter. The galactic oddity was therefore named after the famous Schrödinger thought experiment of quantum physicist Erwin Schrödinger. The galaxy is so far away that its light indicates that the galaxy existed only about 200 million years after the Big Bang. That would make it one of the oldest galaxies we could ever observe. The comparative measurement showed an age that was much lower, and after this confusing measurement, neither age was confirmed. The brightness of the Schrödinger galaxy is another mystery. It seems unusually bright for a galaxy from such an early epoch of the universe, which again leaves scientists with questions about how stars and galaxies formed so quickly. Become a subscriber right now so you never miss another incredible video.